Welcome to another example of time value of money. In this example, we'll look at multiple methods of finding out the present value of an annuity due. Now let us first recall what is an annuity due. So first, what is an annuity? So an annuity is a series of equal payments made at fixed intervals for a specified number of periods. Now, if these payments are made at the beginning of each period, then the annuity is an annuity due. Now, the question at hand is find the present value of the following annuity due. Rupees 200 per year for 5 years at 5%, and assume that discounting occurs once a year. So let us draw the time scale to further understand this example. So this is a 5-year annuity. So 0, 1, 2, 3, 4 and 5. Now the rate of interest is 5% per annum and the annuity amount is 200. So let's say we are getting this amount, and since this is an annuity due, we are getting this amount at the beginning of each year. So at the beginning of first year, we are getting 200 rupees. At the beginning of the second year, we are getting 200. Then third year again 200, fourth year again 200, and fifth year again 200. So now we have to find out what should be the present value of this annuity. So what this means is we have to find out the amount of investment that should be made today in order to be able to withdraw 200 rupees at the beginning of every year for the next 5 years. So basically this amount, when we invest in a bank, we should be able to withdraw 200 rupees at the beginning of the first year, 200 rupees at the beginning of the second year, and so on. Now the investment which is still remaining after the withdrawal of these installments continues to gain 5% interest for the remaining tenure. So let's look at the different methods to solve this example. So the first method we look at is to use the formula for compounding or discounting. In this case, it will be discounting because we are trying to find the present value. Now this present value of the entire annuity can be broken down into multiple parts. Let's break down this present value into multiple components such that each component gives us 200 rupees at the beginning of each year. So the first installment is 200. So this we are getting at the beginning of the first year. Let's say this is PV1. Now again, this is not attracting any type of interest because we are getting at the beginning of the entire tenure. For the 200 rupees that we are going to get at the beginning of the second year, let's say the present value of that is PV2. So this PV2 is an amount which, when invested at 5% per annum, is going to give us 200 rupees at the beginning of the second year. Similarly, PV3 will give us 200 rupees at the beginning of the third year, while gaining 5% interest for the 2 years, and so on. So similarly, we'll have PV4 and PV5. So basically, when you add all these PV1, PV2, PV3, PV4, PV5, we'll get the total present value. So basically, PV is equal to PV1 plus PV2 plus PV3 plus PV4 plus PV5. Now PV1 is 200. So this is 200 plus, how do we find out what is PV2? So we know that future value is equal to present value into 1 plus I to the power n. Why is this so? Because this can be considered a simple case of compound interest, where FV is the value gaining at the end of the tenure, PV is the initial investment, I is the rate of interest, and n is the number of compounding periods. So PV is equal to FV divided by 1 plus I to the power n. So PV2 will become FV2 divided by 1 plus 0.05 to the power 1. Now why 1? Because this is being invested for 1 year and gaining interest of 5% for 1 year only. Plus PV3 will become FV3 divided by 1 plus 0.05 to the power 2 plus FV4 divided by 1 plus 0.05 to the power 3 plus FV5 divided by 1 plus 0.05 to the power 4. Now I hope you understand why this is 4. So let's take the example of PV5. So PV5 has this 200 rupees as the future value. So this is FV5, FV1, 2, 3, 4 and 5. So this is here is going to be our future value. So we have to find out what is the present value, or PV5. So this amount PV5 will be invested for 1, 2, 3 and 4 years. So it will gain interest of 5% per annum for 4 years only. So that's why we have 1 plus 0.05 to the power 4. So now let's solve this. So 200 plus FV2 again is 200 divided by 1.05 plus 200 divided by 1.05 square plus 200 divided by 1.05 cube plus 200 divided by 1.05 to the power 4. So let's calculate this. So this comes out to 200 plus 190.48 plus 181.41 plus 172.77 plus 164.54, and this total comes out to be 909.2 rupees. So this amount, if invested today at 5% per annum for the next 5 years, can allow us to withdraw 200 rupees at the beginning of each of the 5 years. Now this method can become very tedious if the tenure of investment is 20, 30 or 40 or even more years. So let us use the formula for finding out the present value of an annuity due directly. So that is our second method. Now, as we have seen in the previous videos, the formula for finding the present value of an annuity due is present value is equal to A into bracket 1 plus I into bracket 1 divided by I minus 1 divided by I into 1 plus I to the power n. So let us plug in the values. So A is 200 into bracket 1 plus 0.05 into bracket 1 divided by 0.05 minus 1 divided by 0.05 into 1 plus 0.05 to the power n, which is 5. So this is equal to 200 into 1.05, 1 divided by 0.05 minus 1 divided by 0.05 into 1.05 to the power 5. Now let's calculate this. So we'll first take this portion here. So 1.05 x to the power y power is 5 multiplied by 0.05 equals to, and this is 1 by this figure, so this is 1 by x. Now there is a negative sign here, so we'll put a negative sign, and then plus 0.05 reciprocal. So this is the value of the content in this bracket. Now let's multiply this with 1.05 multiplied by 200. So 909.2. So 909.2 rupees. So this is the same answer that we got using method 1. Now let's move to method 3, which is to use the present value factor of an ordinary annuity. Now, as we had seen in the second method, this is the formula to calculate the present value of an annuity due. Now, if we segregate this into two parts, let's say this is one part and this is the second part, then this second part is also the present value factor of an ordinary annuity. However, if we consider one part as this A and second part as this whole thing, then this part, the second part, will be the present value factor of an annuity due. So what is present value factor of an annuity or an annuity due? So basically what has been done is these portions have been standardized in the form of a table with different combinations of values of I and n. So basically that table can tell us the value of these brackets or these portions, assuming that the annuity amount is 1. So that's why this is known as present value factor of an annuity due or a present value factor of an ordinary annuity. So basically, as we have seen, we can find out the present value using two different methods here. One, using the present value factor of an ordinary annuity. So in that case, our formula will become A into 1 plus I into PVFA. And second method is to calculate the present value using the formula with present value factor of an annuity due. So there the formula will become A into PVFA for annuity due. Now in this example, we will use this formula. So let us look at the table for finding out the value of present value factor of an ordinary annuity. In our case, the value of n is 5 and I is also 5. So this is the table of present value factor of an ordinary annuity of rupee 1. I mean, it can be rupee 1, $1, anything which represents a unit of a currency. Now, in our case, we have 5 periods. So n is 5 and rate of interest is also 5%. So the present value factor is the value at the intersection of this row and column, which is 4.3295. So let us use this value to find out the present value in our case. So let us plug in the values in this formula. A is 200 into bracket 1 plus I, so 1.05 into present value factor of an ordinary annuity, which we found out to be 4.3295. So 200 into 1.05 into 4.3295. So 909.2. So 909.2 rupees. Now this is the same answer that we also got in method 1 and method 2. So now let us look at another method, method 4, where we'll use a financial calculator. So the calculator that I have been using for calculations like this is a scientific calculator. So now let's look at a financial calculator. Now while using the financial calculator, we have to consider 5 main buttons. First is N, which is the number of periods. In our case it is 5. Next is I, which is rate of interest, which in our case is 5%. Now while using the formula, we convert I into rate of interest divided by 100, that is 0.05, but while using the financial calculator, we will input the value 5 for I. Next is the present value. Now in this case, we are trying to find the present value. Next is PMT, which is nothing but these payments. So this in our case is positive 200 because we are getting this amount into our pocket. Next button we have to consider is the future value. In this case there is no future value here, so we'll consider this as 0. So let me pull my financial calculator. So first of all, we have to make sure that the calculator is in the annuity due mode. So as you can see, this button here, which is displaying end, this end means towards the end of the year, which represents the ordinary annuity. Now when this button is clicked, there is nothing represented here, so nothing means that it is in the ordinary annuity mode. And this begin, BEG, is for begin. This represents the annuity due mode, so we have to enable this. So now you can see here that this is in the annuity due mode. Now the method to use the financial calculator is to first enter the value and then let the calculator know what that value stands for. So we have N is 5, so 5 is N. We have I as 5, so 5 is I. Next is the payment, so 200 is the value for payments. 0 is the value for future value, and we now have to calculate present value, so we'll calculate present value by clicking this button. So the present value is minus 909.19, which we can round it off to 2 rupees. Now this is the same answer that we also got in the previous 3 methods. The minus sign indicates that this is the amount which is going out of our pocket. So as we had considered the present value as the amount which we'll invest, and then we'll be able to withdraw 200 rupees at the beginning of each year at 5% interest per annum for the next 5 years. So these are the 4 methods to find out the present value of an annuity due. You can use the method which suits you the best.